everyone, welcome to week 48 in the BinarX Student Payload Development Program. Today we are going to introduce you to radio waves and amateur radio observations, and that's in preparation for all the next weeks where we'll be setting up the ground stations and actually playing around with them. But today is for context, so let's get started. All right, so what are radio waves? Radio waves are waves that are part of the electromagnetic radiation spectrum. And you can see where they sit on that spectrum down at the bottom. They are the longest wavelength waves in the spectrum. Now, some of you who are looking at other parts of the EM spectrum are looking in, say, the infrared, which sits here, visible light, which sits there, and UV, which sits there, and I know some of you have explored some X-ray as well. But what I'm going to get you to do now is, rather than trying to explain it all, NASA has some great videos that they've put out explaining radio waves and where they sit in the EM spectrum, and I'm going to let you watch those because those are going to introduce you to some key terms like frequency and wavelength that we are going to be using quite a lot in the rest of this term and through to term 4. So I'll get you to press pause on this video and go over to this week's weekly lesson plan that your teacher should have sent you, and it's got some links to the NASA Introduction to the Electromagnetic Spectrum and another video on radio waves. So pause, watch those, and then come back. So these are the videos here. They're not going to play on here, so just pause me, and when you're done, come back. Okay, so I hope you found those interesting. Don't worry if you don't understand it all. It's just to start getting your head around the terms and the context of what it is that we're doing. But why are we doing this? Why are we setting up ground stations? Now, if I've seen you recently, we've had a little chat about it. We're setting up ground stations. We're going to be building antennas. Well, why do we do this? We're now in the operations and sustainment phase once the satellite's launched, and we're going to be able to track Binar 5 or high school sat with, remember, all of your payloads on board. So here we have, I'll just grab the laser pointer. Here we have Binar 5's payload bay with all of your payloads in there nestled on the microcontroller support boards. If you haven't had a chance for me to chat to you about them in person, you can see where the camera's poking out there. We've got the ones that don't need to see into space down here. We've got our UV photodiode board over here, and we've got our IMU and visible light photodiode board and our infrared thermopiles on here too. So very exciting. Keep working on your engineering models and test if you're still needing to do that. But this is a screenshot from our dashboard at the Binar Space Program from when we were tracking Binar 2, 3, and 4. So yours won't look exactly like this, but you'll see things that you may have seen before, like the waterfall plot. And there is some of, I believe that was us transmitting, but there's some blips where the satellites were. You won't necessarily see this in real time. And there's actually a photo of a webcam of our ground station here at Curtin University. It's got a Yagi on it as well. I believe it's got 4 of them, but ours is on an automatic rotator. We're going to be doing mostly handheld stuff. So yes, we want to be able to track Binar 5 when it's in orbit because your stuff's on there and you want to be able to actually track it in real time, which is pretty incredible. You can also track any other satellite that's flying overhead using SatNOGs, which is a really great amateur satellite observation network. It's global, as you can see there. But if we go into the ground station network on the website, and you go over to Australia and you zoom in, you can see there's a few green dots of ground stations that are currently active. There's not that many. You can click on them and you can see their names. The orange ones are active but in testing mode. So if we click on this one, Gooseberry Hill, and we see it's going to take a minute here. Just wait. It actually does take a little bit of time, so I'm just going to fast forward because it was being really slow. There we go. That's going to pop up, and you can see all the different satellites that you can actually track once you've set up your ground station. So these are all the ones that are going over. It shows you the time. You can click on it, get a little bit of data. That one doesn't have a photo of it. Keep going, and you can search for different satellites, like the ISS, and you click on that, and that'll bring up actually a photo of the satellite in question. In this case, it's the ISS, and then I was looking around for some other ones. You got that one there, which is pretty neat. See if a photo comes up. No photo for that one. Let's skip ahead, try a different one. But you can just kind of click around and play around with these. It's quite interesting. So let me just do a quick search, and there you go, CuteSat, and there, that one's really, really cool there. So you can get these photos of what it is that you're going to be tracking. You can see the observations that have been made. Green means good observations. Let me click on those, and it'll actually take you into the full list of observations that have been made on that satellite. So I'll click on that. And again, it'll take a second because it is just loading off of a big database, and you can see there all the details on the observation, who made it, what time it was made, and then what kind of data was retrieved. So we'll click on this one because it got a waterfall, which is the signal, as well as some data. And you can see if you scroll down there, and I'm circling around it, you got that little signal in the middle. So you'll be creating these as we go through the next few weeks. You'll be setting up your SatNogs account. And this one, I think it got Morse code. I think that's what it was transmitting. And if you went through and listened to the audio for that one, you'd probably hear it going beep, 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 beep. So that's that. We can also track high altitude balloons. So as we talked about, we've got our payloads going on our BinarX high altitude balloon. So the same ground station, the same antenna. You can see me there holding the handheld Yagi. You can bring that up on amateur Sond Hub. If it's an amateur high altitude balloon, that's where ours fall under. We can track those. Or you can also track any other high altitude balloon overhead. Overhead meaning, within a reasonable line of sight. We couldn't do it from totally international, and that's using Sond Hub. So these links are all in your session resources for this week. If I hit play, you can see it might start you, if you've set your location already, it might jump straight to Australia, but in this case, I'm going to drag over, too far, go back, and you can see all the balloons and launches that are currently live. And so, there's one going right now. So this was from earlier today when I actually did this screenshot, and you can see if you click on those, there's different ground stations tracking it, and you click on there and it'll give you some telemetry and some flight data. I'll just show you a little closer my mouse. I'm not sure if that's any good, but it actually will tell you the frequency sometimes, and then you could tune in with your software to find radios and you could get some of that data. But this is kind of a fun one to do too, because these launch actually every couple of days, so it's something you can use to test out your setup between chasing satellites. So it's kind of a bit of fun. So the amateur radio frequencies and bands are the ones that we will be using to track Binar 5 and listen to your satellites. So they're generally in the 420 to 450 megahertz bands. There's a PDF in this week's resources. So this is actually a shot of what we're going to do next week. This is software called SDR++. And you can see on here, it's tuned to 433.195 and change megahertz. Don't worry about this configuration. We'll go over this next week. The waterfall plot, you may recognize that from looking like the SatNogs observations for the satellites. And then there's a little bar here. So you get this cool sort of control panel, and you get to listen to radio waves. So next week we'll do this, but we'll listen to some FM radio. We'll hunt around the radio spectrum, see what we can pick up with those two antennas that you have in your kits currently, which are the little rabbit ears ones and the folding off-the-shelf Yagi. I've also included a quick band plan. So VK is the prefix for amateur radio call signs. I'm not going to get right into that today because there's a lot with amateur radio stuff, which is really cool. And so there's certain bands on the radio sort of window that are reserved for amateurs to listen to and transmit on. You don't need an amateur license to listen to anything. You do need an amateur radio license to transmit. So that could be something that you want to do. We can extend you with that as well. So I've included that in there. And if you have a look, you can see that it's got both the frequencies, so in megahertz or hertz or gigahertz or whatever it is, megahertz in this case, but you can also see, if you look up here, it says 100 meters, 80 meters, 40 meters, and see if you can remember what that relates to in relation to the videos that we watched earlier. So if you do want to obtain your amateur radio license, and this isn't something that is a must do, but it's something that you're really welcome to do, and the amateur radio community has been really generous with us, helping us track all of our satellite missions so far, and our next satellite mission and your satellite mission will be no different. So the ACMA, or the Australian Communications and Media Authority, issues amateur radio licenses, and they keep track of it, making sure everyone's playing by the rules and not causing any harmful interference. You've got Ham College, which is a website. They offer courses, and they actually just do have study resources online as well if you want to start sort of looking into what's involved. And then there are radio clubs in different communities around Australia through the Wireless Institute of Australia. And then in WA, you've got the VK6. So VK is the prefix, and then 6 is, you know, how we have postcodes like, you know, 6,000 here in Perth. If you're in Victoria, it's VK3 because you've got your postcode that starts with 3. I think that's what it is, and sort of corresponds to that. But that's all things you'll learn if you do decide to pursue an amateur radio license. And it's something we can help with because we've all got ours, because that's how we talk to and command our Binar satellites. I even have one, VK6 Meg. You get to pick your call sign too. You can go and see if it's available on the ACMA website, and they have a register of them, so you can see which ones are there and start thinking about what you want yours to be. So your first antennas, there are lots of different types of antennas, and I won't get into how exactly they work, but specific antennas are tuned to different frequencies, and that's based on the wavelength, really, that you'll see, as well as the frequency of, you know, what it is that you're targeting. So what you have in your kit from last year is the telescopic dipole antenna kit. So there were 2 sizes. There's the little short ones and the slightly longer ones that screw in, and then there's the different attachments. And then you've got a folding handheld Yagi antenna in your kit as well currently. That one's good for the 420 to 450 megahertz, so a lot of those satellites. And we'll go over setting that up in a couple of weeks with your SatNog's ground station. You'll have to enter in what type of antenna you have so that you can target the correct satellites that you can actually pick up. And then towards the end of this term, we're going to start building a kit that our Bintern Rayan Atif developed, which is using the PVC pipe and the measuring tapes and some 3D printed parts. And you're going to strip some coaxial cable and solder that onto some measuring tape, and you're going to build your own handheld high-performance Yagi antenna that you can use to actually track satellites. So you won't have to all share the one that you have in your kit now. So that's really quite a lot of fun, and you can see one of our work experience students holding it there. So that's it for this week. Just pack everything up. Make sure you have everything from the kit that has been dropped off to your school by now from week 47, as well as the little software-defined radio dongle, the little RTL SDR, and those other antennas. Also, you'll need to supply an HDMI cable, USB keyboard and mouse, and a monitor. And hopefully you've got either an Ethernet cable that you can just plug right into the back of that Raspberry Pi to connect it to the internet, or if your teachers need to have a chat with me about getting your IT department to set up some kind of Wi-Fi, we'll work on that. So next week we're going to set up your Raspberry Pi, which is the little computers that are in your kits, and we're going to test out SDR++ with the 2 types of pre-built antenna, and we'll do a little radio frequency spectrum hunt. So if you are completely ahead, or you still are working on your engineering models of your payloads, I know we don't have those anticipated values where you've actually pointed them at things and gotten the numbers that they're spitting out. Some teams still have work to do on software, so anytime we come out, we'll still keep helping you with that. But yeah, if we can get ready to set up our ground stations, that is the plan next. Thanks everyone, and we'll see you soon.